Okay, when I factor, first, I look for GCFs. Second, I look for pairs or patterns. Okay. Third, I do the trinomials in whichever method you are most comfortable with, aiming to get towards guess and check. That's what we're aiming to get for everybody. The box and the grouping are just steps along the way. Okay? And then possibly grouping. If you happen to have 4 terms there. Look at that. 1 term. Pairs, that's 2 terms. Trinomials, that's 3 terms. Grouping is when you have 4 numbers in front of you. All right, let's do 21. X cubed minus 144 x squared y plus 108 x y squared. Guys, this is category 6. This is as hard as it gets. This is it. So let's go in order. What am I going to look for first? Greatest common factor. Is there any number or letter that divides everything evenly? Don't yell it. Just sort of look at it for a minute. Okay, so maybe 7. What's your other choice? It's either going to be 7 or 3. 7 and 3, guys. Those are the 2 numbers that divide 21. If there's a number that divides everything, it will be 7 or 3. I would start with the smaller of the 2. Okay? But there's a common x. I see x cubed, x squared, and x means x divides everything evenly. And so maybe, I'm looking at 1 and 21, one of those numbers might divide everything else. I'm going to try the 3 because that's the smallest of the choices. And 144, you can divide in your head, but I'm showing you what I'm doing. I'm seeing if 3 divides everything. Okay, and I'm going to see if 3 divides 108. Okay, so 3 divides everything evenly, and so 3x is my GCF. I'm going to do that first because it's number 1 on the list. When you are showing me your work, you don't have to show me the arithmetic. If you can divide in your head or count multiples, that's fine. Okay, plus second on my list, pairs. Do I have a pair of terms? No, so skip it. Do you have a trinomial? 1, 2, 3, yes. Trinomials are anything that's in that, we'll call it typical quadratic format. You see x squared, ax squared plus bx plus c. It's called quadratic because the degree decreases by 1 each time. So it's possible to have more than 1 quadratic variable. That's still quadratic, guys. It's still a trinomial. Okay? Now we try box, magic circle, multiply, add, grouping, whatever method you want to call it. I'm going to do guess and check. I'm going to write down my possible numbers to multiply to the first term and multiply to the last term. 7 is nice because it's prime. 36, not as much, but I'm still going to do it. The reason that this is nicer is most of the time these numbers are less than 100, and everyone probably, hopefully, memorized your times tables from 9 to 9, right? Remember, maybe? You should be able to come up with these factors pretty quick. Hopefully they still make you do that. Okay, the list is a little bit long, but we're still going to do it. So I'm going to write down my parentheses. And I'm going to put my 7x and my 1x. That is the only way to multiply to get 7x squared. That's it. And so I'm going to, somebody was doing this the other day, and I was like, oh, that's kind of nice. Okay, so I'm going to show you why. I'm going to circle and underline. And I know that both of these numbers should be negative because I have to multiply to a positive and add to a negative. So it has to be minus, minus. Okay, you're either going to get circle, circle, or circle line. That's the only way to pair up these numbers. -1 and negative, really, really, really big number, not -48. Okay, so try the other pairing. -36 and -7. Okay, see that? Circle line. -36 and -7. Those do not add to -48. So that is not the choice. Okay, let's try the next set. Okay, so here's what hold on, sorry. I meant to circle and underline. Okay, so first, 2 circles, 2 lines, or one of each. -2 and negative more than 70. Not it. So I'm going to try it. One of each. -18 and -14 does not add to negative. I'm trying to get to -48. Next. Okay. -3 and -70 something. It does not add to -48. Okay. -12 and -21. No. I would not write this down on my paper if I were you. I'm just trying to show you how I'm checking my possibilities. I'd just be doing this in my head. But I'm trying to show you how I'm systematically going through my choices. You don't want to just stare at it. You want to check off the things that you don't want to go back and reconsider. Okay. I don't want to. Okay, -9 and -28. No. -4 and -63. No. Well, I sure hope it's the last one. That's all I've got left. Okay. Here's my choice. They both have to be negative. -6 and -42. That's it. -6 and -42. Those are the numbers that are going to add to -48. Those might be the only numbers I jot down on my paper. Okay, so you have to place them. Well, they're the same number. Check it. What did I mess up? There's no y. Okay. How do you multiply to get y squared? Y times y. Where are you going to put the y to get the last term to be y squared? After the 6. Okay. Y squared. Do you see how the y squared doesn't really change what I'm doing? It's just how do you multiply to get y squared? Y times y. So let me recheck my work. Okay, so don't leave off your GCF. There is your example. That's as hard as it gets, guys. That's worksheet number 99, where you've got GCFs and multiple letters to look at. Next example. Okay. Okay. 18x squared minus 72. Right? You got to pick numbers that make you think a little bit. Okay? Go through the numbers at the top of your page. What do you do first? It's number 1 on the list. GCF. Okay. Is there anything that divides this evenly? 18, yeah? Oh, hold on. Wait. Fine. I didn't want 18 to divide it evenly. 2. I was going for 2. But you'll see why in a second. 2. 2 is the only thing that divides evenly. Sorry. Okay. 2. Notice that this is not a trinomial. It's only 2 terms. It's the first, it's a binomial, okay? Okay? Notice the quadratic, they're both quadratic, okay? And that means that my middle term is 0. There's no power of 1. The middle term is 0. The inner and the outer are 0. Okay. So I am still going to write down the ways to multiply to get 9. And the ways to multiply to get 25. Because there's not a lot of them. They do happen to be perfect squares. How do I know that? Because 3, 3, and 5, 5. And, well, x, x, and y, y. What are the only ways to make sure the inner and the outer actually combine to be 0? The same terms, the same numbers. Now, this has to be negative, guys, which means 1 has to be negative and 1 has to be positive. So you're going to get positive 15 and minus 15. So let's write down. Now it's still quadratic. Guys, quadratics still factor to 2 binomials. 3x and 3x. And the reason I'm picking the same numbers is because my middle term is 0. All right, and check it. Check it. Foil it. See what happens. Okay, and so it checks. But don't leave out your GCF. What I'm trying to show you is that the multiply, the first and the last, the guess and check, it works no matter what category you're in. You just have to realize that the middle, the missing term is 0, and so my outer and my inner, they actually combine to 0. Now I put a line here because it's a pattern. The pattern has a name. It's called difference. Difference of squares. It's when you have perfect squares. It's an easily recognizable pattern. For example, a squared minus b squared. So a and b are the bases. Okay? This will always factor like this. A minus b, a plus b. It's a formula. It's a formula. I want you to foil this. I want you to check. That means foil it. See if you actually get the beginning line. Yes, it checks. So, if you start with perfect squares, you can use the square root to help you factor, which is the same number. If you start with perfect squares, you can use the square root to help you factor. Use the square root to help factor. Why does this work, guys? Look, it's because of the missing term. The middle term is 0. This is category 3. This is where you're going to spend some of your time today, is investigating what this pattern looks like.
So you can't do that if it's being squared plus less than squared root?
Give me 2 more examples, and we're gonna mention that. But correct, it does not work. All right, example 3. I know, just a little bit. Okay. Okay, you're gonna help me make the problem. Give me a perfect square.
1 plus 1.
A perfect square less than 100, please.
4.
Okay. Give me another perfect square that is less than 50.
4.
I like 16. Fine. I'll be nice. I'll be nice. Just 16. Positive. Hold on. I have to come up with the correct middle term to make it work. I think this will work. I just made it up in my head. Okay. Do you have a GCF? No. Okay, how many of you want to multiply 49 and 16? No, not really, right? Grouping, maybe not a good choice. My numbers are kind of big. Write down your possibilities. Perfect squares don't usually have a lot of possibilities. How do you know it's a perfect square? Oh, 7 and 7. Okay, let's try 16. Okay, I first noticed that I have a perfect square. Okay, now I can go through this process and I can check every possibility. But your number is 56, guys. Look at how you're going to multiply and get 56. First thing I notice is that I have to multiply to a positive and add to a negative, which means both of these numbers need to be negative. You can start wherever you want with trying, okay? I don't really want to multiply any of these numbers by 49 because I think they're going to be too big. And so I'm going to start with 7 and 7. Okay, I'm going to start here. There's no reason that says you can't start at the bottom of your list instead of the top. 28 and 28. It's 56. It's because I saw they were perfect squares and I was like, gee, I wonder if it works. Okay, I also didn't want to start by multiplying by 49, so I tried 7. Okay, this is where you go through your list pretty quick. What's 7 times 16? Ooh, 70. Really big. I don't like that choice. It's too big. I don't think it's going to get me close to 56. 7 times 8 is 56 and 14. Too big. 28 and 28. Oh, okay. I like how you said the word perfect because there's a name for this pattern. 7x and 7x minus 4 and minus 4. Okay, check it 49x squared. Guys, I actually expect you to FOIL in your head, but I'm writing down that I am checking my work. Minus 28 plus 16. It's called, oh, isn't that the same thing written twice? It's called a perfect square trinomial. Okay. Do you need to know it's a perfect square trinomial to factor it? No, I just factored it. It just has a special name because it ends up factoring in a special way. The same factor twice, so it has a specific name. Perfect square trinomial. Because it was 3 terms to start, but it ends up being the same thing multiplied together twice. Perfect square trinomial. Okay. And so it's a formula type pattern. A squared plus double the inner and the outer. Double, right? 28 and 28. Double. And it factors like this. It's not really an equals. It's like a biconditional. Like these things go back and forth. Like they equal each other. Check it. I want you to actually FOIL this and see that it gets you the first line. It's a formula. It's called a perfect square trinomial because I had perfect squares and it happened to be the same numbers. Give me a perfect square, less than 100.
4.
81, I like it. Give me another, 4, I like it. No, 4 is good. Does it factor? Does it factor? Yeah, the answer is no. But why? Why doesn't it factor? It's not a difference of squares. Okay? You might be thinking this. You're like, oh. Does it check? Does your inner and your outer add to 0? No, it adds to negative 36. So, it's not a perfect square trinomial. It's called prime. Prime means it does not factor. One and itself. This is it. If you are going through your list and it doesn't work, even a regular trinomial, you say prime. Because it does not factor, which is why you have to systematically eliminate your choices. Because if you get down to the bottom, you're like, it didn't work. Well, your answer might just be prime. But you have to be confident that you didn't miss a possibility. Yeah. Before we're done, quadratic formula indiscriminate, we will talk about how that can be connected to factoring. So, yes, you could try it and be like, oh, this doesn't work. Okay, that's it, guys. When you get back from lunch,